Welcome to datascience.show, the podcast where data science meets executive leadership. We talk with top AI and analytics thought leaders about turning data into real business impact. If you're a C-level leader or data expert shaping the future, you're in the right place.
Welcome to datascience.show. I'm your host, Mirko Peters. We explore how data science and AI drive real business impact, straight from the leaders making it happen. Today, a practical executive playbook for industrial AI in production. How to turn sensor data and models into reliable, auditable services that actually move the business needle. Why this episode and why now? Industrial systems run for decades. They have physical risks, safety obligations, and economics that depend on uptime, quality, and predictable cost. Too many teams chase shiny pilots without connecting to operations, safety, and long-term maintainability. Today, I'll give a compact, no-nonsense roadmap for C-level leaders to greenlight the right work, de-risk deployments, and measure the value that matters.
First, a quick framing exercise. In most organizations, the core stakeholders are operations, reliability engineering, data science, IT/cloud, procurement, and safety/compliance. You'll see programs start in analytics or digital initiatives teams, but to scale, they must become operational products, owned by someone accountable to uptime and cost. If you don't have a clear product owner and cross-functional SLAs, projects stall.
Let's talk typical starting points and risky patterns. A common beginning is an early warning or predictive maintenance pilot, a few machines instrumented, promising short-term uplift. But pilots often fail to account for sensor drift, variability across sites, maintenance feedback loops measured in months, and procurement cycles for edge hardware. The result? A model that works in the lab and flounders in production. So how do you move from strategy to execution? Start with portfolio criteria that separate high impact from high risk, low return bets. Prioritize use cases that are tightly tied to measurable operational KPIs. Think MTTR, unplanned downtime, yield, safety incidents, where incremental improvement yields clear cash or risk reduction. Repeatable across multiple assets or sites, and feasible within existing instrumentation or with low-cost sensor upgrades. Require a clear hypothesis, data availability check, and a 90-day operational milestone before further investment. Edge versus cloud. This is not ideological, it's architectural economics. Put inference close to where latency, safety, or connectivity matter. Real-time control loops and emergency stop logic belong at the edge with hardened software and strict change controls. Cloud is for batch analytics, long-term model training, fleet-wide aggregation, and heavyweight experimentation. Design clear boundaries. Edge for critical latency and resilience. Cloud for stale, historical context and model lifecycle management. Also, ensure your edge nodes can operate offline gracefully and log enough telemetry for later reconciliation. Data quality and sensor integrity are the unsung heroes. Before any modeling, require a sensor health baseline, signal-to-noise metrics, calibration history, timestamp alignment, and missing data patterns. Instrument metadata, firmware version, sampling rates, physical mounting nodes. Build automated sensor diagnostics that run on the edge and in the cloud. If you deploy a model on bad inputs, you'll automate bad decisions, which is expensive and sometimes dangerous. Model design for industrial environments needs robustness by design. Favor simpler, explainable models that fail in predictable ways over black box complexity that's brittle. Enforce fail-safe modes. Models should degrade to conservative operator defaults when confidence is low, and systems should require explicit operator acknowledgement before any control action with significant physical impact. Embed uncertainty estimates, domain rules, and operational thresholds into the inference pipeline. Human-in-the-loop and safety controls are not optional. In many industrial contexts, models must recommend actions and a trained operator implements them. That handoff needs crisp UX, low latency alerts, and audit trails.
Maintain an evidence log, inputs, model version, confidence, operator decision, and subsequent outcome. These logs are essential for continuous improvement, compliance, and incident investigation.
Integration into control and operations demands strict change management. Treat models like software releases, code reviews, testing, unit, integration, and replay tests on historical telemetry, staged rollouts, and rollback plans. For safety-critical loops, require hardware-in-the-loop or digital twin validation before any production deployment. Without these practices, you'll create operational friction and erode trust. Now, leadership and organizational design. Create a single product owner for each industrial AI service, accountable for the end-to-end SLA. That person must be empowered to make trade-offs across engineering, ops, and procurement. Define cross-functional SLAs, data availability SLA, model latency SLA, MTTR for edge hardware, and an observability SLA for telemetry retention. These SLAs should be contractual where vendors are involved. Procurement and vendor contracts must include reliability and observability clauses. Insist on metrics for uptime, model performance drift, and clear responsibilities for firmware and security patches. Require vendor support for remote diagnostics and a commitment to backward-compatible updates. Put service credits or performance-based payments in place for critical services. That aligns incentives and reduces long-term operational risk. How should executives decide? Use a simple ROI framework. Quantify the operational impact, reduce downtime, improved yield, safety event reduction. Estimate implementation and operational costs, sensors, edge hardware, integration, change management, and model risk-adjusted timelines for when benefits materialize. Require a break-even horizon appropriate to the asset class. Heavy machinery may justify multi-year payback, but short-cycle assets need faster returns. If a use case can't show a credible path to positive net present value within that horizon, deprioritize it.
Measuring success means operational KPIs, not model accuracy alone. Track incident reduction, mean time to detect, mean time to repair, yield improvement, and operator adoption rates. Complement those with observability metrics, inference latency, model confidence distributions, sensor health indices, and drift alerts. Tie executive compensation or program funding to those operational outcomes to keep teams aligned.
Looking forward, emerging risks and opportunities. Expect regulator scrutiny to increase in safety-critical industries, so build auditability and reproducibility now. Maintainability will be a competitive differentiator. The teams that can sustain models across firmware updates, changing sensors, and shifting operating profiles will extract more value. Also watch for commoditization of edge inference and standardized telemetry frameworks that reduce integration cost over time. Over the next 12 to 24 months, prioritize building durable practices, strong sensor diagnostics, conservative fail-safe defaults, vendor SLA clauses, single product ownership, and an ROI gate at the portfolio level. These investments may feel less exciting than new model architectures, but they are what converts pilots into sustained operational value.
To close, 2 actionable steps you can take today as an executive. First, require a data and safety readiness review before any production sign-off. Include operations, safety, and procurement in that review. Second, implement a portfolio prioritization gate, functional SLAs.
Final reflection. Industrial AI is not about proving a model can predict an event. It's about integrating that prediction into reliable, auditable operational services that reduce downtime, improve safety, and deliver measurable financial returns. That's the difference between models and value. If you found this episode valuable, subscribe and share it with your network. And let's connect on LinkedIn. I'm Mirko Peters. We'll be back with more conversations on how data science and AI create real business impact. Until next time.
Thanks for listening to datascience.show. If you found value in this episode, subscribe, share it with your network, and join us next time as we explore how data science drives smarter decisions and better business outcomes.